Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Most benchmarks ask one lazy question: did the model win? This paper asks a harder one: did the model actually understand what it was seeing? Win rate sounds objective, but it's a black box. It collapses strategy, luck, heuristics, and overfitting into a single number. A model can win repeatedly while holding completely wrong beliefs about its opponent. If we care about theory of mind like reasoning, that's a huge blind spot. So the authors change the role of the LLM. It doesn't play rock, paper, scissors. It observes. Two agents play the game, sometimes static, sometimes bias mixtures, sometimes reactive rules like win last or copy last. The LLM watches the sequence of rounds and predicts something very specific: the full probability distribution over win, draw, and loss. Not a guess, not a label, a calibrated forecast. Think weather prediction, not will it rain, but what's the chance? The clever part is the ground truth. Because RPS is simple but non transitive, they can analytically compute the outcome distribution for any pair of strategies. Even for adaptive players, they run a damped fixed point solver until strategies converge. That steady state distribution becomes the answer key. So the LLM isn't graded on vibes, it's graded on math. Each round, the observer gets the strategy catalog, recent game history, and a zero shot chain of thought prompt. It explains its reasoning and outputs probabilities. Those probabilities are scored immediately with three signals. Cross entropy measures surprise, Breyer score measures calibration, expected value loss checks payoff intuition. Did the model get the advantage right? They normalize and average these into one metric called union loss. Here's the first big pitfall: low variance is not learning. Some models look stable because they barely update their beliefs at all. Second pitfall: low loss doesn't mean the model can name the strategy, so they add strategy identification rate as a separate commitment check. The takeaway is subtle but important. Understanding isn't about winning, it's about calibrated beliefs that update with evidence. By turning LLMs into observers, not players, this framework gives us a much cleaner lens on what they actually know and where that understanding breaks. If you found this helpful, hit like, subscribe, and comment which agent system you want to build next. Stay sparked. See you in the next video.